good afternoon, good evening. My name's Jordan Lord. I'm going to be talking about the PureScript programming language today. Just sort of a short disclaimer before I start. I've never really done a talk like this before. And I'm no sort of expert in PureScript, but I do think it's a really cool technology, and hopefully I can sort of present that in a decent way tonight. So PureScript is a transpiled programming language, a bit like TypeScript, a bit like ClojureScript, CoffeeScript, LiveScript, Helm. All these languages are transpiled to JavaScript, and PureScript is another one of those. But it makes us ask the question, especially with languages like TypeScript and CoffeeScript. They are very similar to JavaScript in some ways. So it sort of makes us ask the question, what is wrong with JavaScript? Is this language terrible that we're here? We're actually meeting up today to talk about this language, and it's actually a bad language, is it? Why can't JavaScript just be normal? I mean, in what language does an empty object plus an empty array equal 0? Where's the logic behind that? There's not really any types at JavaScript. I mean, there is sort of like crappy little types, but yeah, there's not really any types. We've always got to choose between a double equals and a triple equals. And again, for a beginner, the very little subtleties between those two can be really confusing. And here's sort of another example of the comparisons. I think this sort of shows that there isn't really any logic behind the empty object plus empty array equals 0. We have to choose between let, var, and const. I mean, we should know when to use const or when to use let/var, but the differences between let and var are very, very subtle. And again, for a beginner, that can be really sort of confusing. We've got two different types of nulls. We've got null and undefined. We've got not a number, nan, and we've got infinity. Again, it doesn't really make much sense to a beginner. I mean, this is a perfectly valid example of mutating an object. But in JavaScript, we don't really have any immutability. So you can pass an object to a function, and it can change the state of that object in that function without you actually realizing it. And some libraries actually do this. And it can be really difficult to debug what's actually happened. We can get kind of immutability. I'm going to sort of justify that last statement a little bit. Immutable JS, of course, we can use things like that. But it's not actually baked into the language. Again, we can have the side effects in JavaScript. A function that does look like an innocent, pure function might actually be starting World War III. Which, I mean, if this is a piece of code in the let's say the North Korean military missile testing, whatever, and we accidentally execute launch missile, then we're starting World War III without intending it. But it's all a bit silly, all this, because these arguments, we know to use the good parts of JavaScript. We know to use triple equals instead of double equals. We know to use, I can't remember the other example now, but we know to use the good parts of JavaScript. So what is actually PureScript? I'm not talking about JavaScript today. I'm talking about PureScript. Well, PureScript is a purely functional programming language. It's strongly typed. It has Haskell-y syntax. So if you know Haskell, then you'd be able to pick up PureScript very easily. And it compiles to sort of readable JavaScript. Not kind of like CoffeeScript and TypeScript, but you can sort of reason with the code that has been compiled. And the types only exist at compile time, so it's a statically typed programming language. I mean, why don't we just use Haskell? Because we can compile Haskell down to JavaScript. But Haskell comes with a bit of a runtime when you do compile it to JavaScript, so it's much lighter weight to compile PureScript, to use PureScript in Haskell. I'm going to take a little bit of a detour for a second. So who actually knows what this machine is? Yeah, for those that don't know, this is the BBC microcomputer. It was released in the early 80s. Believe it or not, I actually started programming on this machine. It was my dad who introduced me to it. And he was showing me games like Elite and Manic Miner. But I was sort of more interested in how to program it and make it do things. I was fascinated by how you basically had to program it to do anything. That was the interface to it. And for a long time, for a few years, like when I was probably 10 or 11, I was programming in BBC Basic. And a lot of people told me that this was bad, it pollutes your mind, Basic. Also, try something like Java. So I tried Java for a little bit. I didn't really like the IDE. It was too complicated and it was too awkward to set up the JDK. So for a long time I was programming in BBC Basic. But eventually I came across JavaScript. And what I did like about JavaScript was that all you needed was a text editor and a web browser. And you could basically reach anybody in the world. You could share your JavaScript applications with your friends. And it was brilliant. So for a long time I programmed in JavaScript and decided that's what I wanted to do as a career. I wanted to be a software developer. So I started as an apprentice at a company called Sage. I was doing .NET, C# stuff. And finally I got into Java, a bit of Java there. But then I decided I wanted to do something a little bit more theoretical. So I came to university here in Bristol, the University of Bristol. And we have a Haskell module. And this is where I got into Haskell. And I was blown away by Haskell, the power of it, the expressiveness of it. And when I went back to programming JavaScript, it was always a bit awkward. It was like, oh, I want these nice features of Haskell in JavaScript. And I tried LiveScript for a little bit, which is kind of like an extension onto CoffeeScript. But eventually I came across PureScript and I was satisfied. And that was the holy grail almost. And now I'm working for, I'm going into my second year at university. And I'm currently working for a company called Zuba VR this summer. So we do sort of virtual reality applications, mixed reality, augmented reality applications. I've been getting involved in a few really interesting projects there with WebAR, JavaScript, Socket.io, React, RxJS. So it's been pretty interesting. But back to PureScript. I don't think the PureScript logo displays very well there. But yeah, this is where the talk gets a lot more boring. I'm going to go through like the basics of like the language. So to get started, you need to install the PureScript compiler, Pures. I don't know if that's how you pronounce it, but you can install that from the website or with a package manager. PureScript actually still uses Bower as a package manager. I believe this is to do with how it handles dependencies. I don't know why they haven't really switched to NPM or something else yet, but they use Bower and Pulp. Pulp is the build tool for PureScript that you'll also need. Creating a new project, Pulp init, dev server. So this is like your Webpack dev server, and PureScript REPL. So I can actually quickly. Actually, I'm not going to demonstrate that because this is a different monitor. So, but you can bring up your PureScript REPL. So functions. Yeah, functions in PureScript. This is how functions are defined. So you have your function name, and then you have the function's type. So all functions are defined as you have your input type, and then you have an arrow, and then you have your output type. So it's very similar to Haskell if you know Haskell. But all functions have one input and one output. Here's an example of just adding two. You'll see this throughout the talk. All the examples are really sort of uncreative. But here's add to, so we take a number and we return a number, and we're taking the parameter x and then adding 2. And this is just a normal JavaScript number. If you omit the decimal point from the end and just write the number 2, the compiler will infer that it's an integer. PureScript has integers, and this will not compile. But what happens if you want more than one input to a function? PureScript takes, I've just said that a function takes one input and produces one output. But here we want multiple inputs. Again, this is another really uncreative example. I'm literally aliasing the plus operator. But all functions in PureScript are curried. It's easier to see here. So when you give it a parameter, if you give the function an argument, it will return a new function that will be looking for the next argument, and then it will keep doing that until you actually return the result. So here we're accepting a number, and then we're returning a function of type number to number, and then give it another parameter, you'll finally get your number out. And this is just an example of using that function. But what this is really useful for is, so here we have the map function. So in JavaScript, where we would have to define a lambda, and we would have to have like x arrow x plus 42. In PureScript, because all functions are curried, we can have map and then just omit the other parameter to the function, and then it will just sort of work. So creating types. In PureScript, we can define new types. So these work very similar to just normal objects in JavaScript, but it checks the types before compile time. Here we're creating a user with username string, email string. And here we're actually using the, we're going to actually print out that user. So show user is taking a user and returning a string. And here we've obviously got just the normal JavaScript style syntax for an object. And here's username and email. And there's the string it returns at the bottom. But again, all the type inference and the type checking is done at compile time. So if I went username equals 42, then the compiler would say, no, you can't do that. So new type. New type is a bit like sort of wrapping an existing type in another type. So here we've got an email, and we're sort of wrapping a string as an email. So we're saying an email is a string, basically. Why would you want to do that? Well, it's very useful for validation. So here's a function that's passing an email. So it's testing our email string that we passed in to the regex. And if it does pass, then we're returning. Here we're actually using the data constructor for email and wrapping that string as an email. And then if not, we're returning an error message. This was actually ripped off from another talk, so I didn't create this. But this is useful for validation, because what we can do here is we can export the parse email function, but we don't export the data constructor. And what that means is every time you ask for an email anywhere in your application, you know that email could have only been created through the parse email function, so that email would definitely be valid. Here's an example of exporting email. So that's the type constructor and exporting the function parse email. And importing is exactly the same, basically. Algebraic data types. So algebraic data types are a bit like enums, but they work a little bit differently. So here it's behaving exactly like how an enum would behave. User type can either be a guest, a member, or an admin. But we can use it for more complex tasks. So here we're actually using algebraic data types to create a list. So a list can either be empty, nil, or it can be a chain of a value and another list. Type classes. So type classes behave very similar to interfaces in normal object-oriented programming. So here we're actually defining the show type class, and it only has one function, which is show, and then a to string. And here we're actually implementing the show type class for our user type before. And here's a kind of a cool feature of PureScript. We're using pattern matching. So instead of writing a bunch of if statements, if user is guest, else if user is admin, or a switch statement, we can just write, well, show if we're showing a guest, this is what the guest string would be, show member, and so on. And again, here's an example with our email new type, as we described earlier. And here we're actually unwrapping the email type to get the string out and return that string. Side effects. So you can actually represent side effects in PureScript, but you have to sort of specify in the type that we're using. We're returning a monad, which is here we're actually using the effect monad, and yeah. So you can actually see if you think you've got an innocent pure function that's going to be starting World War III, you can actually see in the type that it's not such an innocent pure function. It will be returning an effect of something. So I'm going to show an example of an isometric 3D cube written in PureScript. So here's just I hope that's clear enough, but that's just a cube that's rotating. And this is purely written in PureScript. So I will bring up the code. And the cube is defined here. So the cube is a new type that wraps a matrix of type number. And again, this can be defined however it wants. But we implement this again, it's a little bit confusing because got two different new types here, but we're implementing the new type data, I can't remember the name of it now. We're implementing new type of matrix number, and as long as this cube type here can be unwrapped to a matrix and can be wrapped up again from a matrix, that means it's renderable. So if I bring up the renderable type class, so for something to be renderable, it has to implement a new type of matrix number. And again, for something to be renderable, it also has to be transformable. So that's sort of the power of the type system. And here's another type that I defined, which is a pyramid. And again, this wraps matrix number. It doesn't necessarily have to wrap a matrix number, but as long as it unwraps and wraps to, then that's fine. And if I go to main.PureScript and change cube with pyramid, and hopefully that will recompile. Then refreshing the page, so passing that pyramid in, will then start rendering the pyramid. So yeah, I was actually going to do some live coding, but it was probably boring enough as it was. So yeah. But what happens if you already have an application that's written in JavaScript and you want sort of the power of PureScript in that application? You don't want to build your application from the ground up in PureScript using like that 3D example was. But it's actually really, really simple to integrate PureScript into your current application. So we can We can run pulp in it, or we can just create we can do Bower in it, and we can install the default PureScript modules like PureScript Prelude, but just make sure to remove the default main.PureScript. But what makes this really easy is the Webpack loader for PureScript. So installing that, and then adding the PureScript Webpack loader to your Webpack config, it's then really simple to incorporate into your application. So I have an example application. Yes. So if I do npm start, yeah, so this is just a really simple React app where when you click add 42, it'll add 42 to the total. But what happens if we want that logic and shift it into PureScript? So I'll open up the root component. So here, this add42 function is taking the current state and it's returning a new state and adding 42 to it. So if we remove that, then the application should no longer work. Add42 doesn't do anything anymore. But I want that add42 function written in PureScript. So I'm going to create a new file, source. Let's call the module add42. Module add42, so this is defining a module, and then we're going to export the add42 function. Where and the add42 function will take the current state and return a new state. Add42, we will then can destruct, and just like you would in ECMAScript 6, get the total out of it, which is there, and then return a new object where total is going to be total plus 42. But we also have to define state as a type. Total is going to be of type int, and we'll also have to import prelude, not 42, plus. And then rebuilding the application, it doesn't work. Let's debug why it doesn't work. It compiled. I think I know why, because in here we didn't import it. So if we import this add42 function from add42.PureScript, it should seamlessly sort of work. And it does. So here we've got the PureScript code, and it's passing, it's calling the add42 function, which is defined in PureScript. And that's how easy it sort of is to integrate PureScript into your current application if it's built with Webpack. I mean, PureScript does have a lot of disadvantages. So you are basically learning a new language from scratch, which if you're working in a team, that's a big problem because everyone then has to sort of learn this new language. There are also some breaking changes. So with that 3D example that I've showed earlier, I wrote that with PureScript 0.117, and a newer version of PureScript was released and things just didn't seem to compile, and I was wondering why it works on my desktop but it doesn't work on my laptop, and my laptop had the newer version of the PureScript compiler, and that's why. But I guess if you're running this in a production environment, you would have a Docker container with a specific version of the PureScript compiler installed, so that wouldn't be too much of a problem. But advantages, it's like I've just showed, it's really easy to integrate PureScript into your current application. It's very expressive. It's easy to reason about states. There's a large library, so a lot of the PureScript sort of standard library, which I'll show in a minute, sort of like aliases a lot of the standard browser functions. And the type system is designed to work with you. It's not like, it's not there. How can I describe this? Yeah, the type system's there to work with you. It has a very powerful foreign function interface. So if you have an existing PureScript application and you want to use some of your JavaScript in it, then it's very easy to do that with the foreign function interface. And I think the number one reason advantage of using PureScript is that it's actually fun to use. It's a fun language. And here are some of the resources that aren't very clear to see. So PureScript by example, this was written by the guy who wrote PureScript, Phil Freeman. This is sort of like the standard book. PureScript documentation repository is useful. Try PureScript, that's a bit like CodePen, but it's PureScript, and Pursuit. So for those that know Haskell, this is very similar to Hoogle. And it's very sort of easy to look up a function that you don't know. So if I don't know what the dollar operator does, there it is, it applies a function to an argument. Or let's say if I wanted to find a function that took a number to a number to a number, and there's a list of functions that take a number, and return a number. So the max function and the min function. So it's a really really useful resource. And that's it. So if you want to find the slide, it's at jordanhill.co.uk/intro to PureScript. Thank you very much for being patient.